Welcome to computational physics, the land where Excel does all the dozens of calculations that you'd rather not do yourself. Fill in everything you know about your roller coaster already. At what speed did the passengers get on? Where did the passengers get on the ride? And I don't mean the top of the staircase, I mean when they entered the park. Put in all your speeds from the simulator. Check. Does your roller coaster end on ground level? If so, you know the height. If not, leave this blank. This simulator will tell you the height. However, you do know the speed at which your passengers get off, and you know the kinetic energy that is going to be. Where is your ride going to get its energy from if everyone is starting originally on ground level at the bottom of the staircase? Talk about the energy sources you have from your design at the start of your ride. Where does the gravitational potential energy come from? Where does the kinetic energy come from? Talk about where that energy is going to go. After you brake with a tremendous screeching noise, what is going to happen to all that kinetic energy in your ride? Just for kicks, fill in the number of meters of track that you expect to use. If you're lucky, this won't make a difference. The longest roller coasters in the world are 2,000 or even 2,200 meters of track. Mine is not the longest roller coaster in the world. I think I only have about 1,000 meters of track or so. Coefficient of friction for the braking stretch? We'll worry about that later. Press pause, fill in your data, press play when you're ready to check your work. Now, let's see what Excel can do for us in terms of formulas. We already know the formula for kinetic energy. Type in equals. That is how you start writing a formula in machine language. Always, always, always type in the equals. Kinetic energy equals 1/2 mv squared. So there's your 1/2. Now times. Do not forget that times sign right there. In algebra, you can write letters and numbers right next to each other, and everybody knows you mean to multiply, but you can't do that when talking to a machine. You have to put in the times every time. Times. M. Click on here where the mass is. Do not click anything else. Do not touch anything else. Do not breathe on anything else. Very carefully type times. Now we'll go over to the speed. Click. There! Highlighted it. We'll go back and fix it later. Squared. Carefully type in that square. Do not click anywhere else. Hit enter. There. Well, that was anticlimactic. 0 meters per second means 0 joules of kinetic energy. So we go back to this. Now fix. There's only one mass. It's never going to change. In Excel, never going to change. Absolute cell reference is a $sign. If we're really paranoid, we can put in 2, not just 3 columns to the right of wherever we are. We really mean cell J2. Really, it's only the 2 that's going to make a difference, but you might as well put in the extra $sign. Be paranoid. G is a relative cell reference. Your speed is going to change. Look, it changes to different values over the course of the ride. Now, press enter. You can copy this formula and you can paste it anywhere you like. Of course, if you don't like all that clicking, see over here in your home menu, fill down. Isn't that nice? Look at all those lovely numbers, all your kinetic energies. Of course, messes up the lovely, lovely color coding, which is a pity, but only a few clicks should fix the color coding. Keep the color coding, it means something. There. Save your work if you haven't already. You have all the kinetic energies for every important design point in your ride. Now, potential energy. Let's see, potential energy is mgh. Well, we know that over here. Wait. Yep, we know that over here. But, here. Here we go. There's another point. We also know the height. That's why it's called, this formula is going to be different than the others. Equals m times g. That's 9.81. Times h. Go over here and click on it. Now, go back. Make your actual cell reference so it keeps the mass. Press enter. Now, we're ready for our total. Our total energy should equal kinetic plus potential. Look at that. Our ride has about 720,000 joules of energy to work with. This is our magic number. Copy it. Right-click, paste special, all sorts of wonderful things. Just paste the value. Or if you really want to type in 717,925, you can do that too. You have to do 717,925 joules of work in order to get your total energy to start the ride. And once you have the total energy to start the ride, that total energy is not going to change. Go in and paste it throughout, or better still, if you don't want to paste a bajillion times, set this equal to cell E4. Absolutely, cell E4, our total energy. Nothing else will do. Now that we can paste, that we can fill, that we can fix our formatting, and if you really want to just type it in by hand, you can do that too. Save your work if you haven't done so already. You know exactly how much energy you need in order to run this ride. Now, that ought to make a lot of things easier. You know that kinetic plus potential equals total. Here, you don't know the potential. But if you have 720,000 joules of energy, and you've used 11,000 of them, follow along, press enter, I'm on your left. Bless my soul, you have 706,000 joules left. Rock on, copy that formula, paste it. You have potential energy. Here and here, you know the height. You can practice doing M, G, H on your own in those nice blue cells where you know the height. Practice doing M, G, H without following along, and the breaking stretch where you definitely know that it's flat. If your breaking stretch is of an unknown height, you'll do this at the end. Use this formula here. Save your work. Now, check it out. You know from your formulas that if U equals mgh, and you know U, then your height is going to be U divided by, open parentheses. Do not forget to open those parentheses. M times G, close your parentheses. Proofread everything. Make this an absolute cell reference. It's got to be the same mass throughout. Press enter. There's the height of your roller coaster. Copy this formula. Paste this formula. Fill it down. Son of a gun, this is your roller coaster design. Your first hill is 110 meters high. Your loop goes up to 66 meters. Your second hill goes even higher, and you have a breaking stretch in the land of flatland, which is interesting because you do not appear to have used all 720,000 of your joules. You appear to have some to spare. See how much? Take the total energy. Take away your kinetic. Take away your potential. Follow along. Oh, you appear to have done about 60,000 joules of work. Well, not you personally. Friction. Go back to your white cells. Ooh, notice I clicked somewhere. Shouldn't have done that. Press enter. Go back to your white cells. Click. Paste. Make sure the cell references actually match, or, better still, do the whole formula again. Total energy minus kinetic minus potential. Don't click anywhere. Just press enter. There we go. That's doing what it's supposed to. Copy that. Paste that. There we go. Now, if friction has done almost 60,000 joules of work over the ride, check that out. Over here, work done by friction. You said friction had 1,000 meters, or whatever your length of track was, to do the work. Work is force times displacement. That means work divided by displacement is force. Look at that lovely formula. If the track is basically flat the whole time, which it isn't, but we'll take AP Physics to do the trigonometry and the calculus for that, this is the coefficient of friction your ride had throughout. I guess you were serious when you set it to 0, but nothing's perfect. This is your exact coefficient of friction for a ride of those dimensions. And if your ride ends on ground level, then you're going to need to do all 720,000 joules of work in order to stop the ride. All of that kinetic energy has to be worked off sooner or later. Wait a minute. Kinetic energy. That's worked off already. Actually, you need this. Copy that value. Paste that value. You need to work off, in your case, because friction did a little work beforehand, you need to work off your kinetic energy. That's how much work friction or your brakes are going to have to do. Now, if you have a coefficient of friction of 1.2 on a nice rough braking stretch, the formula says you will need 86 meters of braking stretch. If you want a higher coefficient of friction for a rougher track, then you'll only need 73. If you want to coat the rails with sandpaper, then maybe you can get away with only 16 meters, which is already 180 feet, which is the size of about a block or two of braking stretch. Plan your roller coaster accordingly. Look at the heights, look at the track length and the braking stretches, and start your designing.